Now we'll be solving question number 17 from exercise 2 of laws of motion chapter. It's a piece 1. So with what minimum acceleration can a fireman slide down a rope whose braking strength is 2/3 of his weight? So fireman is sliding down and the rope braking strength is 2/3 of his weight. So obviously if the fireman is not sliding down, the rope will break. So something that sliding down is doing by which this will not break. This is the fireman. And let's assume the fireman is coming down with acceleration A. Tension will be T in this case. So let's make the FPD. So there are two forces acting upon this fireman. One is downward, which is G. Second is tension, which is upward. And the acceleration is A. Now as a rule, the direction of acceleration is taken as positive. So mg will be positive and tension will be negative. So we'll get mg minus t is equals to F is equals to m. I'm applying. Or you can say t will be equals to mg minus ma. If I take m common and mg common, if I take, I'll get 1 minus a by g. Now, according to question, the maximum value of t should be 2 by c. You cannot go beyond that. So at the critical time, critical condition, the t will be equals to t max, and that is 2 mg by c. So let me write the value at critical point. So 2 mg by c is equals to mg 1 minus a by g. Mg and mg cancel. So 1 minus a by g is 2 by c. So a by g is 1 by 3. And that makes acceleration as g by 3. Meaning if the man is sliding down with the acceleration g by 3 or more than that, the spring will not break. If the acceleration is less than g by 3, the spring will break because the tension will go beyond 2/3 of its weight. Okay. So I hope you understand this question. Thank you.